Have you ever wondered how a material lighter than your phone but way tougher than steel gets made? Seriously, this stuff is a game changer, and it's quietly reshaping everything from our sneakers to the spaceships blasting off into orbit. This is the wild, fiery origin story of carbon fiber. It all kicks off with this weird, gooey, stringy material called polyacrylonitrile, or PAN for short. Imagine a high-tech version of taffy. This goop gets stretched into incredibly long, thin fibers, thinner than a human hair. At this stage, they just look like a spool of regular white thread, nothing special. But this is where the magic begins. These fragile-looking white fibers are sent into a series of giant industrial ovens. This first step is called The heat isn't insane just yet, but it's enough to make the molecules inside the fibers do a little dance and then lock together super tight. Think of it like a sports team getting into a huddle before a big play. They re-getting organized and becoming a single, stronger unit. As they bake, they transform from pearly white to a mean jet black color. They're getting tougher, but they're not even close to being the superhero material we know. Next up is the main event, carbonization. This is where things get really, really hot. We're talking thousands of degrees Celsius in an oxygen-free environment. The ovens are cranked up to an extreme temperature that burns off almost everything that is unpure carbon. All the other elements, hydrogen, nitrogen, you name it, are vaporized and just yeet out of there. It's like taking a marshmallow and toasting it way past golden brown, past burnt, until you're left with just a little black diamond of pure carbon. Except this is done on purpose, with insane precision. The intense heat forces the carbon atoms to arrange themselves into super strong, tightly packed crystal structures. This process is what gives carbon fiber its legendary strength. The result is we're left with fibers that are so incredibly strong they could literally tow a car, yet they are so lightweight they feel like they're barely there. If you hold a spool of it, it feels almost weightless. It's this strength-to-weight ratio that makes engineers go nuts for it. It's like having the strength of a bodybuilder in the body of a marathon runner. But raw carbon fibers are a little slippery and don't like to play nice with other materials. To make them usable, they have to go through one more step called surface treatment. The fibers get coated with a special chemical finish. This coating acts like a primer, roughing up the surface just enough so that it can bond tightly with resins, which are basically super strong glues. It's like giving the fibers a fresh pair of sneakers with awesome grip, so they can hold on tight inside whatever structure they become a part of. Without this step, the final product would just fall apart. Now that the fibers are prepped and ready, they're woven into fabrics. This is where the iconic look of carbon fiber comes from. Robotic looms, moving with hypnotic speed and precision, weave these black threads into massive sheets. You've probably seen the most common pattern, the twill weave, which looks like a sleek, futuristic checkerboard. But there are tons of different patterns, each designed for specific properties, some for flexibility, some for insane rigidity. Watching these machines work is like seeing a sci-fi movie come to life. They create these beautiful, shimmering black cloths that look like armor for a spaceship. These woven sheets are still just flexible fabric, though. The real transformation happens when they're combined with a resin, like epoxy. Layers of the carbon fiber cloth are laid into a mold, saturated with the sticky resin, and then cooked under heat and pressure in a giant oven called an autoclave. This process, known as curing, fuses the fibers and the resin together into a single, rock-solid piece. What comes out is no longer a fabric. It's an incredibly tough, rigid, and lightweight panel. This is the composite material that gets used to build high-performance cars, airplane wings, pro-level bicycles, and even the chassis of high-end gaming gear. The primary keyword here is aerospace. In the world of planes and rockets, every single ounce matters. Lighter planes are more fuel efficient, and lighter rockets can carry heavier payloads into space. For aerospace engineers, carbon fiber is a total cheat code. It allows them to build structures that are just as strong as metal, but at a fraction of the weight. The Boeing 787 Dreamliner, for example, is about 50% composite materials by weight, a huge leap that makes it one of the most efficient airliners in the sky. But here's the cool part. Carbon fiber isn't just for fancy billion-dollar tech anymore. It's sneaking into our everyday lives. You can find it in high-end phone cases that are super slim but incredibly protective. It ests in fishing rods that are light enough to hold all day, but strong enough to reel in a monster fish. It's used in tripods for cameras, making them stable yet easy to carry. It's even in musical instruments like guitars and violins, giving them a unique sound and incredible durability. It's become a flex in product design, a visual signal that tells you something is premium, durable, and high-tech. Here's a little experiment you can try. For the next week, just pay attention to how many products you see that brag about being carbon fiber reinforced. You'll start noticing it everywhere. It's a marketing buzzword for sure, but it's one that's backed by some serious engineering. So, what's next for this super material? As manufacturing techniques get better and cheaper, we can expect to see carbon fiber pop up in places we never imagined. Imagine construction beams that are light enough for 2 people to carry, but strong enough to support a building. Or car frames that are so light they dramatically increase the range of electric vehicles. Maybe we'll even see it integrated into the clothes we wear or the furniture in our homes. And here's the real plot twist. The original process for making carbon fiber is pretty energy intensive, but scientists are already cooking up new, eco-friendly ways to produce it. They're experimenting with bio-based starting materials, like lignin from wood pulp, to create a greener version. This hints at a future where this incredible material is not only ridiculously powerful, but also planet-friendly. The holy grail would be a carbon fiber that is strong, light, cheap, and sustainable. And we're getting closer to that reality every day. So the next time you see that sleek, black woven pattern on a car's dashboard or a piece of sports equipment, you'll know it's not just there for its good looks. You'll know that it's the result of some serious heat, some mind-bending chemistry, and a whole lot of engineering magic. From a simple gooey string to a material that builds the future, that's the epic journey of carbon fiber. Thanks for watching, and if you learned something new, be sure to hit that like button and subscribe for more deep dives into the materials that shape our world. See you in the next one.